Hey guys, so I made a video about the empty product. I talked about 2 times 3 to the 0, and I said 2 times 3 to the 0 is the same thing as 2 times no 3's. So there's nothing there. It's just 2 times a lack of 3's. And that would still be a 2 because there's no 3's changing the number. We still do have a number right here. We can't just say 2 times empty space or empty product. So we have to say 2 times something. In order to keep this equal to 2, that'd be the same thing as 2 times 1. This is a demonstration of the empty product and why 3 to the 0 is equal to 1. If you want to see it a little bit slower, check out the link in the comment below. We'll put a box around this. I've had a lot of people ask me this follow-up question. They said if we do 2 plus 3 to the 0, that's the same thing as 2 plus no 3's, and that would give us 2 because we're not adding any 3's to it. And that'd be the same thing as 2 plus 0. And from here, it looks like 3 to the 0 is equal to 0. So how do we feel about this? I'm going to explain why this isn't true. First, let's talk about what is 2x plus x. This is equal to 3x. Why is that? Because there's an implied 1 in front of that x. Or what about 2x squared plus x squared? Well, that's equal to 3x squared. And why is that? Because of the implied 1. So it'd be 2 plus 1 is 3. So what about 2x to the 0 plus x to the 0? Well, that's 3x to the 0 because of the implied 1 right there. So let's go back to this up here. What is 2 plus 3 to the 0? Well, first off, just like this x to the 0 had an implied 1, this 3 to the 0 has an implied 1. So this ends up being 2 plus 1 times no 3's. So it's the 1 that's being multiplied by no 3's. So this is the same thing as this red box right here. So I'm going to put a red box around this. Since this 1 is being multiplied by no 3's, it's still a 1. And so this ends up being 2 plus 1 equals 3. And what does this empty product have to be equal to make this true? It has to be equal to 1. And for this reason, 3 to the 0 is equal to 1. Please keep the questions coming. I love them. You guys are awesome.